Is it a foul? Is it a flop? These are big issues in professional basketball. How do you tell if a player is responding naturally or is faking it? This is the Locomotor Performance Laboratory, part of SMU's Annette Caldwell-Simmons School of Education and Human Development. Researchers in this lab use high-tech instruments to study the scientific basis of human performance and now the biomechanics of basketball.
So our flopping project investigated 3 questions. The first question is, how much force in a collision does it take to cause a legitimate loss of balance? The second question is, are the forces in typical basketball collisions above that minimum threshold? And the third question is whether or not we can tell from a player's response to a collision whether his motion is real or contrived in a way to get the referee to call a foul, in other words, a flop.
So for more than a year, this team from the lab conducted experiments to get answers to 3 questions. Question number 1, how much force and impulse does it take to knock a player off balance? It depends on the player's height, weight, and body position. Researchers made predictions based on Newton's laws of motion and built a mechanical player to test the models. The results came out just as predicted. They also did the same tests on humans over a range of height and weight. Once again, the results lined up with the predictions. They both conformed to Newton's laws of motion. The finding was startling that it takes only a small force and impulse to knock a player off balance. Depending on size, body position, and point of contact, an impulse of 20 to 100 Newton seconds will knock a player off balance. That's typically about 50 pounds for a quarter second when the player is upright.
Many individuals wonder, why are these forces so small? The balance point has such a short distance to move within the base of support. The base of support just being the area surrounded by the foot where the player's foot is in contact with the ground. So there's a very little force required to move that center of mass outside of the base of support in order to knock the individual off balance. So another player jogging to another player is sufficient enough to knock them off balance. Now moving to an everyday situation, such as a kid walking through the hallway at school or a mother at the grocery store, simply another individual walking into someone else would be enough to knock them off balance.
Question number 2. What forces and impulses actually occur in a basketball collision? Using an instrumented push bar, they established that they could accurately measure impact forces and impulses through motion capture. Then they conducted human-to-human collisions, where one player was stationary.
We had to go to an indirect measurement method, so we used Newton's laws and the 12-camera motion capture system in order to determine the range of forces and impulses in actual basketball-type collisions.
The results from the basketball-type collisions showed that the actual impulses exceeded the threshold to knock a stationary player off balance. How do you measure whether a player is stationary? The lab tests show it takes a quarter to half a second to plant the feet and stabilize the player's center of mass. So, finding number 2 is, if the feet are planted and the body stabilized, any basketball-type collision is sufficient to cause loss of balance. Question number 3. Was it a natural reaction or was it a fake? Researchers at SMU posed a variety of contact situations and recorded human reactions to identify natural and unnatural reactions. They used the principle of conservation of momentum. Take these 2 billiard balls. The one moving has incoming momentum due to its mass and velocity. The second has mass but not velocity, hence no momentum. When they collide, the first ball slows down, the second speeds up. But the total momentum is unchanged. It's the same when one player collides with another. If it's a natural reaction, the total momentum stays constant. However, if the total momentum increases, it means additional forces were introduced. In a game situation, other observable criteria can be used.
So when the torso gets contacted, the natural motion of the arms is to come slightly in front of the body. Now, in a human player, the same natural reaction will occur. As the torso gets contacted, the arms are going to rise up slightly in front of the body. After the collision, the arms might reach back behind the person as they brace for impact. In an unnatural reaction, however, the arms are going to immediately rise above the body as excessive motion is introduced.
Finding number 3. The conservation of momentum is a valid scientific method for evaluating normal reactions to collisions. In a game situation, other observable criteria can be used. There must be actual contact between the two players, and the player's response to the collision must be appropriately timed to the impact. This study concludes that there are 3 categories of reactions to basketball-type collisions. 1. The player reacts naturally and steps back after contact. The player reestablishes a new base of support and doesn't fall down. 2. The player reacts naturally and falls down because of the inability to step back quickly enough to establish a new base of support, or due to intentionally keeping the feet planted. And 3. The player reacts unnaturally, exaggerates the effect of the collision, and adds excessive motion after the impact. Planting the feet and stabilizing the body take less than half a second. The force and impulse to knock a player off balance are small. Any basketball-type collision will have sufficient impulse to cause a loss of balance. Therefore, to identify natural versus unnatural reactions, the focus should be on the following criteria. Body and feet are stationary. Actual contact has occurred. Response timing is appropriate. Arm motion is not excessively upward.
So there are all sorts of implications of the work because we have answers to those questions that had been unaddressed before. And so the work generalizes to prosthetics and robotics and animations, being realistic, as well as to healthy and clinical populations and things that those people need to do to maintain balance in their everyday lives.